In this section, we'll look at rules for antidifferentiation. Every continuous function has an infinite number of antiderivative functions, which differ by only a constant. And in order to acknowledge that issue, when we find an indefinite integral, what that means is we're going to be finding a family of functions. And we want to use the letter C to stand for any constant. Now, in the expression that's shown here, we're taking an integral of f of x. It's an indefinite integral, it's called, which just means that there are many possible answers. And we want to find the antiderivative, which is big F. Now, once we find that function, big F, we can't stop there. We have to also add plus c to acknowledge the possibility that there could be many different answers to the question. In many cases, that constant c will stay unknown, but it could be any value. So we'll just leave it. In some problems, we'll actually be given more information where we can determine what that value of c is. But in these problems here below, we won't know what it is, so we'll just leave it as a c. For the first one, it asks us to use the antiderivative notation and write an expression which says find the antiderivative of 1. For that, we want to first just write down our function that we're taking the antiderivative of. Then we want to use that antiderivative symbol on the left and then put a dx on the right. That is the notation that is being referred to. The integral sign and the dx are like parentheses that say find the antiderivative of 1. For the next one, try to find an antiderivative of 2. First, we'll write the expression which just tells us to do it, and then in the next part, part C, we'll actually do it and find the antiderivative. So for starters, just write down your function, 2. Then put your integral sign on the left and dx on the right. And that tells us to do the operation of finding the antiderivative. Now we need to think of a function whose derivative is 2. So whereas f of x could be 2, big F of x would be the antiderivative function, which would be 2x. That's a function whose derivative is 2. So what we want to do here to actually solve the problem is to write that antiderivative of 2x, but we can't stop there. We have to finish the problem by putting plus c to acknowledge that there are many possible answers. It could be 2x plus 1, it could be 2x plus 2, 2x plus 3. Any of these would work, right? So that's how we'll answer the question. All right, so the general rule for the antiderivative of a constant m is to make it into mx plus c. We want to use that general rule to answer the rest of the questions here. Find an antiderivative of 5 using the rule above. The antiderivative of 5 is 5x, and then we'll put plus c. To find an antiderivative of negative 8, just attach it to x. And then put plus c to finish the problem. Pi is just a constant. It's a number, so it fits the general form here. We'll make it pi x plus c. And here's an interesting one. A function whose derivative is 0. Well, that would be any number. So let's follow the pattern above and see what it simplifies to. It simplifies to simply c, a constant. So the antiderivative of 0 is just a constant.